So welcome to the last session on probability. Here we are going to discuss on expectancy and variance. Last class we had the definitions of expectancy and variance. We derived many useful results. Let us have a quick recall of what we did. Expectancy of x is defined as is nothing but the average value, and we defined it as minus infinity to infinity x into f of x in case of a continuous variable distribution. In case of a discrete distribution, we defined it as sigma xi into probability of xi over the range. This is the discrete case, correct? And variance is nothing but mean of square deviation. So variance is nothing but, see, we discussed the idea of finding the variance also. Expectancy is like a mathematical machine. So whatever I feed into this machine, it gives the average value of that. So if I feed in square deviation, it will take the mean of the square deviation and give me. So expectancy of square of deviation, that is x minus mu the whole square, where mu is nothing but e of x. This e of x is also called as mu. Correct? Because deviation is nothing but, what is deviation? Deviation is nothing but x minus x bar, correct? So x minus mu here. Clear? This what? And this eventually turns out into e of x square minus e of x the whole square. Both are not same. Observe where I am squaring it. Okay. So this is what is variance of x. So we use this concept, the definitions, to prove various results. That is, expectancy of ax plus b is nothing but a expectancy of x plus b. Expectancy of constant. Expectancy of a constant is constant itself. Then variance of ax plus b is nothing but a square variance of x, and variance of a constant is 0, because constant variance is going to show how much the quantity is going to vary. Constant cannot vary, so it has to be 0. Clear? So these were the results we derived last time. Now we are going to solve problems related to this. The first problem we are going to solve is f of x equal to 2x in 0 less than x less than 1, 0 else. Okay, is a probability density function. Find its mean and variance. Find its mean and variance. So what is we are asked to find? E of x is what we have to find. Okay, it's a probability. Okay, let me complete this. Of x. Okay, expectancy of x. What is expectancy of x? Expectancy of x is nothing but minus infinity to infinity x f of x dx. So this should give me integral minus infinity to infinity. See, but f of x is defined only in the range of 0 to 1. In the range 0 to 1. In the range 0 to 1. So minus infinity to infinity, I cannot directly write it. So minus infinity to 0 x into f of x, I am splitting it, plus integral 0 to 1 x f of x, plus integral 1 to infinity x f of x dx. Here f of x is 0, here f of x is 0. So these parts are immaterial. So e of x eventually turns out to be 0 to 1 integral x into 2x, which is the value of f of x dx. Okay. So if I integrate, what means, if I will be getting integral 0 to 1 2x square dx. So if I integrate this, I will get 2 into x cube by 3 between the limits 1 and 0. So it becomes 2 by 3. Correct? 2 by 3. Then now we have to find variance of x. This is the expectancy of x. We have to find variance of x. Variance of x is nothing but e of x square minus e of x the whole square. Correct? This is nothing but see now let me e of x I knew. E of x I found out, so I know this value. I need to find e of x square. So if I find e of x square, I know e of x, I can find e of x the whole square. I have to find e of x square. If I find e of x square, I can find variance of x. Correct? So now the next step is to find e of x square. E of x square is nothing but what? Whatever I write here, we have to write it here, right? Minus infinity to infinity x square into f of x dx. The f of x is defined only in 0 to 1, rest all the places it is 0. So this would become 0 to 1 x square into f of x 2x dx. So this is nothing but what? This is nothing but e of x square will be what? E of x square will be what? E of x square will be 2x cube, right? 2x cube. Now 2x cube on integration will give me 2x power 4 by 4 between 0 and 1. This is nothing but how much? If I substitute, it will be 2 by 4. This is nothing but 1 by 2. So let me call this as result 2. Let me call this as result 1. Now using 1 and 2, variance of x will be what? It will be 1 by 2 minus 2 by 3 the whole square. Correct? There is nothing but 1 by 2 minus 4 by 9. Correct? So when you simplify it, what will you get? The LCM will be 18. 9 minus 8 by 18 you will get. So the answer will be 1 by 18. This is the solution, variance of x. The answer is 1 divided by 18. 1 by 2 minus 4 by 9 will give you 1 by 18. Clear? Fine. Let us proceed. So f of x is a probability density function of x, and it's given by 6x into 1 minus x in the interval 0 to 1. 0 else. Find the mean and variance. So again it is only the function has changed, rest everything is same. So mean is nothing but e of x. This is nothing but integral minus infinity to infinity x f of x dx. So when we try to solve, actually f of x is defined only in the region 0 to 1. So it eventually turns out into integral 0 to 1 x into 6x into 1 minus x dx. So what we will get? We will get 6x square minus 6x cube between 0 to 1 dx. This is nothing but integral. If I integrate it, I will get 6x cube by 3 minus 6x power 4 by 4 between 0 and 1. When I substitute the limit, I will get it as 6 by 3 minus 6 by 4. 6 by 3 minus 6 by 4. Can take 6 common outside. 1 by 3 minus 1 by 4. This will become 6 into 1 by 12. This is nothing but half. Correct? Okay. Now we have to find variance of x. Variance of x is nothing but e of x square minus e of x the whole square. So I know what is e of x now. I know what is e of x. The question is to find e of x square. So how we'll find e of x square? E of x square is nothing but integral minus infinity to infinity x square f of x dx. So when I substitute the thing, what we will get? It's nothing but limits. When we substitute, we will get only 0 to 1, because other places f of x is not defined. X square into 6x into 1 minus x dx. So this will become 6x cube minus 6x power 4 integral 0 to 1 dx. So on integrating, we will get 6x power 4 by 4 minus 6x power 5 by 5 between 0 to 1. So it turns out that 6 I can take out, 1 by 4 minus 1 by 5. So this will be 6 into LCM would be 20, 5 minus 4. So 6 by 20. On simplification, it gives me 3 by 10. Okay, fine. Now V of x is nothing but e of x square minus e of x the whole square. So let me call this as result 2. Let me call this as result 1. In result 1, I know what is e of x. In result 2, I know what is e of x square. So v of x can be found. So this is nothing but 3 by 10 minus 1 by 2 the whole square. This is nothing but 3 by 10 minus 1 by 4. This is nothing but LCM can be 20. LCM will be 20, correct? LCM will be 20. So 6 minus 5, this will be 1 by 20. This is the variance of x. Clear? Now this one is a bit different. The sense we have to integrate up to infinity here. Because x greater than 0, it is e power minus x, 0 else. Find the mean. It's going to be little bit bigger here. E of x is nothing but integral minus infinity to infinity x f of x dx. So f of x is defined only for positive x. So we will have 0 to infinity x into f of x dx. This is nothing but integral 0 to infinity x e power minus x dx. Now how do we integrate x e power minus x? We have to use integration by parts. We have to use integration by parts. So integration by parts means, remember we have this rule ILATE, inverse, logarithmic, algebraic, trigonometric, exponential. Whichever we hit first, that will be the value of u, and the other one will be, the remaining part will be dv. So x inverse, logarithmic, algebraic. Algebraic is a function which is x. So dv will be e power minus x dx. So by rule what we know, u dv is nothing but uv minus integral v du. Correct? So our u is x, dv is e power minus x dx. So you have to find du. Du becomes nothing but dx. V is nothing but integral dv. This is nothing but integral e power minus x dx becomes minus e power minus x dx. Clear? So therefore integral x e power minus x between 0 to infinity dx is nothing but uv, that is u is x into v is minus e power minus x e power minus x between 0 and infinity minus integral v du. V is what? What is integral minus integral? v du between the limit 0 and infinity, we have v is minus e power minus x. This minus can be brought outside and written as e power minus x dx into, correct? I'm sorry, y dx will come here. E power minus x only will be there. E power minus x into v du. Du is dx. Clear? E power minus x dx. Clear? Dx won't be here. Okay. So when we substitute the limit, what we will get? When I substitute infinity, see this part is little bit tricky. When you substitute infinity, you will get infinity into e power minus infinity. What will be infinity into e power minus infinity? Infinity into e power minus infinity will be what? Will it be infinity or will it be 0? The answer infinity into e power minus infinity will be 0, because infinity is trying to grow. See, the value of x here is trying to increase this function. E power minus x is trying to pull down this function. Correct? Now, it is a race between x and e power minus x, what value this will take. But x, the increase is in a linear fraction. X is an increase. Correct? X is as x, when you put infinity, say if I put infinity as 1 lakh, x will take 1 lakh. This part will take e power minus 1 lakh. If I put it as 2 lakh, this will take 2 lakh into e power minus 2 lakh. If I put infinity as 1 crore, this will take 1 crore into e power minus 1 crore. Observe that x is a linear function, whereas e power minus x is a exponential function. So, the amount by which x is trying to increase, e power minus x would have gone many folds decreased by that time. So, e power minus infinity will always be a much lower number than infinity. So, the value will be 0. Okay. Then when we put x as 0, we will get 0 only. So, it becomes 0 minus 0 plus integral 0 to infinity. This part is bit tricky here. Understand the concept here. That's very important. The remaining part is very easy. E power minus x dx. This on integration will give me what? Minus e power minus x between 0 and infinity. When I substitute the limits, I will get the value as 1. Because what we will get? Minus e power minus 0 minus minus 1 we will get. Lower limit minus upper limit, right? So 0 minus of minus 1 will give you plus 1. This is the mean. Now I give you an assignment here. I want you guys to find the variance of x. What is variance of x? Okay. And I want you to find the value of variance of x. Okay, I want you to find the variance of x. Variance of x, how can you find? Variance of x is nothing but e of x square minus e of x the whole square. We know what is e of x. Your job is to find e of x square. E of x square is nothing but x square minus infinity to infinity f of x dx. So use the appropriate thing here and find v of x, and the answer should be 1. The v of x should be 1. So find it yourself and find that v of x is 1. Okay, we have found e of x. The only thing remaining is to find e of x square and subtract it. Subtract e of x the whole square from e of x square. Find the value of variance of x to be 1. So this one is a totally different problem. A firm has sent bids to 3 contracts whose profits are rather bids for 3 contracts. English is bid. Bids for 3 contracts whose profits are $10,000, $20,000 and $40,000 respectively. If probability of winning contracts are 0.2, 0.8 and 0.3 respectively, what is the expected profit? What is the expected profit? That is, the probability that the contract worth $10,000 profit will be 1 is 0.2, $20,000 will be 1 is 0.8, $40,000 will be 1 is 0.3. So, what is the expected profit? Now, the question is this You are solving the problem. So is this continuous distribution? No. The answer is no, because it's a discrete case, correct? You can either see, you can get this and get this, like see, there are three jobs. So each one is separate thing, and there are totally three events only, 1, 2, 3. So it is clearly discretized. You cannot say that I am sending 1.2 contract, 1.11 contract, 1.7 contract, like that, correct? So it's a clear case of discrete. It's not continuous, it is discrete. So in discrete case, what is E of x? E of x is nothing but summation in range x into p of x, xi into p of xi, correct? This is what we studied. That means what? That is, we have to find what is the probability that the contract 1 will be 1, and so this is what? The probability, first thing is the 10,000 rupees, $10,000 contract, the probability that will be 1 will be 0.2, plus second thing is a $20,000 contract, the probability with which it will be 1 is 0.8, plus third one is the $40,000 contract, the probability with which it will be 1 is 0.3. So it will be how much? 2000 plus 16,000 plus how much? This will be 12,000. So the total answer will be how much? It will be actually $30,000. Correct? See, actually the thing what I have done here is not mathematically correct. Okay, let me explain that. That's a really good point to understand. See, now these three are three independent events. Okay, the contract that the company will get a contract on this is totally independent of this and this. Similarly, that the company will win this contract is totally independent of this and this. Similarly, the company will win this contract is independent of this and this. So there are not one random variable, there are actually three random variables. x1, x2 and x3, there are three random variables. Okay, so this is the expectancy of random variable 1. This is the expectancy of random variable 2. This is the expectancy of random variable 3. And we know that E of x1 plus x2 plus x3 is nothing but E of x1 plus E of x2 plus E of x3. And E of x1 is 22,000. E of x2 is 16,000. E of x3 is 12,000. That's how we got this. Clear? Because, okay, let me redo this here. What is E of x1? E of x1 is nothing but x into p of x. Here this is x into p of x. Here this is x into p of x. So the probability the company will get this contract, the expected value is what? Here it is 2000 into 2. This is 0.2. This is 16, how much? 20,000 into 0.8 plus 40,000 into 0.3. This sums out to be $30,000. Clear? Is this clear? Fine. Okay, this one is bit different and interesting. So here f of x is a density function of x. F of x is given by a plus bx square in the region 0 to 1, 0 else. If expectancy of x is 3 by 5, find a and b. So now how to solve this? This one is interesting really. So what are the clues? F of x is a density function. If f of x is a density function, integral minus infinity to infinity f of x dx is 1. That means integral minus infinity to, the function is defined only in the range 0 to 1. That means integral 0 to 1 a plus bx square dx should be 1. Correct? So when I integrate this, what will I get? Ax plus bx cube by 3 between 0 and 1 should give me 1. That is a plus b by 3, and when I substitute 1 I will get a plus b by 3. When I substitute 0 I will get 0 only. So a plus b by 3 equal to 1, or 3a plus b equal to 3. Let me call this as equation 1. Now what is e of x? E of x is nothing but integral minus infinity to infinity x f of x dx. So this is nothing but integral. Here in the given case this will be integral 0 to 1 a x into a plus bx square into dx. So upon solving, what will I get? Ax plus bx cube integral 0 to 1 dx. If I integrate this, what will I get? Ax square by 2 plus bx power 4 by 4 between the limits 0 and 1. So this is nothing but a by 2 plus b by 4 minus 0, and this value is given to be 3 by 5 given in the problem. Correct? Expectancy of x is 3 by 5, right? It is given to us in the problem. It is given to us in the problem. So what we will get here? This can be written as 2a plus b by 4 equal to 3 by 5. Upon simplifying, what we will get? 10a plus 5b is equal to 12. 10a plus 5b is equal to 12. This is the second equation. So we have two equations, two unknowns. This could be solved directly. Correct? So 3a plus b equal to 3 and 10a plus 5b equal to 12. So upon solving it, what will you get? So upon solving, we will get a as 0.6 and b as 1.2. Clear? This is the answer. Clear? So we have seen problems related to discrete and continuous distributions, and we have seen different models of it. So with this we finish the class on probability.